Howdy, folks. Glad to have everybody back for, I think this is the 12th episode, could be the 11th. I'd have to go back and count to be absolutely sure of the platform thinking podcast that we've been working on. Podcast in general is just trying to explore all the possible viewpoints or the many viewpoints people have about platforms, platform engineering, all these kind of topics that people have brought up recently. And try to kind of get a better idea of how we might think clearly about what a platform is and how to manage, develop, govern all these ideas a platform. And so in that way, I'm really excited to have my friend Bill here, Bill Bensing. Bill has been writing books recently. One of them is excellent, and you guys should all go read it. It is about automated governance, which is a topic that we will be discussing in kind of platform frame today. But also, Bill's been working with developing prototyping software for doing these governance processes. And I think he's just a really interesting person to talk through some of these ideas with. So, Bill, do you want to introduce yourself to everybody?
Yeah. Well, thanks for that introduction. I love being here with you, Jabe. As we've worked together, your intellectual depth, I will be honest, a lot of the stuff that I've been able to talk and think about, your opinions, especially from the scope economy and things, have really helped form it. So I'm excited to be here today. But yeah, so a bit of my background, as I tell people, I came from the shadow IT. I was the business person that through high school I learned how to write software, got into industry, and then realized with Notepad and a compiler or the most popular server, which is Excel, I could write any type of lot of software, and so that's how I got into doing things. And security and compliance was always the number one thing that was you can't do this because X, and then I would ask, well, how do you do X? And I could never get a clear answer. So within the past 5 years, I've taken on this sort of passion-driven mission to figure out how can I always think about people like me, who Bill was back when he got out of college, just writing on PHP, and wanted to bring something into a large Fortune 50 organization. How could you allow that to happen, make it happen, and make it so? Because my personal belief is when you do that, you align business and IT such that it is now it's a top line advantage for the company.
Cool. So I like to start with everybody just to kind of frame our conversation so that people kind of have an idea of how we are thinking about a platform right now. I like to ask the guest, hey, how would you define a platform? How should we think about a platform for this episode?
So I will tell you what a platform's not, as far as I'm thinking through this. It's not a way to deliver software. Now, I have a lot of anti-platform and no platform stuff out there. And the reason I got into this mode is because I read the book Platform Revolution. And it was about 18 months ago. I really wanted to dig in and understand this word platforms, because you hear it used all over the time. Vendors love to call whatever they have a platform. And so this Instagram approach to marketing and software these days, part of it is this search for truth, but it's also me trying to understand sort of how can I, how can we, there's a lot of people listening. So how can we help educate them the best? And so for today, as I start thinking through a platform, I'll be honest, I'm stealing a lot of my stuff straight from the Platform Revolution and thinking that is the business model of a platform. And they make some really good arguments, and I'll talk through a lot of that today. But a platform's not just stitching together software delivery tooling. Can you build a platform that enables software delivery? Yes, but there's a lot more to platform than just putting all these tools together, Kubernetes, yada, yada, you name it. There's a lot more than that. And for the technologists here, what I really would love for them to walk away with today is what the business side and the business model platform looks like, because there are constraints and there's questions that I'd argue you should be asking yourself, because the question is, do you have an engineering productivity approach or do you have a platform approach? And those are very two divergent approaches. One, platforms begs the solution. So that's context I want to bring into today.
So in the context you're talking about, you're trying to point out that treating a platform as like a CI/CD pipeline and or like a as something that services particularly DevX kind of things, that is a reduction of what we could mean by a platform. It's kind of like it kind of treats the platform as being less than it could be or something like that. Yeah.
You've nailed it. Yes, I think when you do that, you're right. I love the way you say it. It's a reduction of what a platform could be.
Yeah.
And I think it puts constraints around the idea of a platform. Because when I think about platform, like a platform is designed around a core interaction.
Yeah.
So think about Facebook. Yeah. Think about Twitter. Think about Amazon. What's the core interaction? Facebook is an exchange of information, right? Same as Twitter. Amazon is an exchange of goods. Yeah. And so when you start to think about platform, one of the things is like there's multiple providers. It's based on network effects. Yeah. So the whole idea is to amplify the network effects of all of the participants such that you have this exponential value creation.
Right.
So I think once you start to do that, and this is where I get engineering productivity, you can achieve the same things people talk about right now with developer platforms by not having a platform approach. And I'd argue you maybe shouldn't, because when I look at the resources of a company, are they best spent trying to figure out how to generate network effects inside of a company, or are they best spent on what the company's core value proposition is? But I'll stop right there because I want to dig deep into a lot of this. Yeah.
Yeah. I mean, there was this tweet by Kelsey Hightower the other day that kind of feels roughly like what you're saying. And Kelsey basically was arguing that people shouldn't adopt Kubernetes, that in fact it was a distraction. People are spending way too much time trying to manage something that was reasonably complex and difficult to do. And that kind of the ground is shifting under all the time. And so his argument was like, you shouldn't, like, most people probably don't even need Kubernetes right now, but also you have to be very careful when you're choosing to treat that as a platform, as kind of the way you're talking about, right? Like this idea that Kubernetes is a way of delivering a package of functionality via containers and orchestration is overly difficult for most organizations right now. And I think his argument is roughly like, you just don't do that. There's so many other ways of solving this problem. Anyway.
Well, like I want to get to actually, let's use that example real quick, because I love the SRE book.
Yep.
If you read, and was it chapter 7, The Evolution of Automation at Google, it talks about Borg. And for those that know, Borg was a predecessor to Kubernetes.
100%.
And this is talk about like how platforms are, when you talk about platform and developer productivity, how it's really not meant to be. So I want to draw a bit of an analogy here. So help keep me on the rails with this one. The reason Borg, and i.e. Kubernetes, was invented was really a capacity planning problem. You had a lot of capacity at Google across different data searches at different data centers, and really a team had a rack of servers that wasn't 100% utilized. And so you get at Google scale, you get all of this excess capacity. 100%. And so something like Borg was designed for bin packing to take this capacity and actually use what you need and then shift around. So that's where the concept of the warehouse-sized data computer came from, right? And so instead of virtualizing something, breaking something bigger into smaller pieces, you took smaller pieces, made it one big piece. That right there is the core value of Kubernetes at its heart. And I would argue the vast majority of people who are using Kubernetes probably have never even heard that, let alone aren't using it for that use case. And so that's where I get into like the platform and like the complexity. Now, don't get me wrong. I love Kubernetes. A lot of things that I will start on there, but things like, well, now like Amazon has ECR, like containers are a nice way. Like don't conflate containers and Kubernetes. Containers are a nice way to package and deploy, but you don't need Kubernetes to manage containers. So as we're getting into it, like I want to show the mixed measure. We talk about platform versus developer productivity and like Kubernetes versus, like my argument is if you look at Google and their automation, like they had 5 steps to it. If you can't fully repurpose a machine in your organization on a whim, then you don't need Kubernetes. Like there's so much delta in automation, and Kubernetes came about because automation had hit its precipice fundamentally in Google. And so I think right now, like that's my argument for why a lot of people don't even need to consider it. But then the counter argument would be like, well, nobody's going to take the time to figure it out. So could we do this like little catch-up effect thing? And
totally.
I don't want to go down that route, but like showing the parallels of complexity, like that's.
I think like one of the things we've been saying at Ergonautic is everyone wants to have a SaaS. And in order to have a SaaS, they need to have something like a PaaS. And the problem is they haven't solved that. And then additionally, because they want a PaaS, they need an IaaS. In other words, they need infrastructure as a service or infrastructure as code, or however you want to say that. And almost nobody solved that either. So kind of like pointing out the kind of thing that you're pointing at, right, is that if you don't have ephemeral infrastructure, like that in a way that you can literally say, I don't care what's on any particular machine. I care if I have enough compute. That's what I like. Until you actually are able to ask and answer that question reasonably well, some of the other platform stuff you're just basically building on quicksand, and you're just going to have another long-lived environment with a different interface, basically, which seems to like totally miss to me what we're trying to get to.
It's technology is doing geeky things to be intellectually stimulating. Mm-hmm. And like at the end of the day, you always ask the question, what's it doing for the business? Sure. And, you know, if you can't provide a very clear line between we have a capacity problem, this, that, then it's like this hyperbole of what we could possibly potentially do this like now. But yeah, you're right. Yeah.
And I have a couple other thoughts there. So the first one is like, one of the bottlenecks that I see in a lot of organizations that's related to this conversation we're currently having is that they continue to say we have a development environment, we have a QA environment, we have a UAT environment. And what they mean by that is they have machines dedicated to those environments. They have infrastructure that's dedicated to those particular environments. Mm-hmm. So there's the capacity issues that you're kind of pointing at, like how often is that dark? How often are we like, how much utilization are we getting out of infrastructure, right? So that's one question. And there's some efficiencies to be gained there, and I think that's interesting. But secondarily, it becomes a constraint in that if you have a long-lived, if you have built a UAT, for instance, on the assumption that it's long-lived, what you probably have to do is every time you run a UAT test, you have to reset the environment. So you have to get all the databases have to get back the same way, and all like you have to have the right starting point each time, right? So that means that the UAT environment gets used, and then it goes offline for, I don't know, however long it takes you to like reset it. And that is a bottleneck because people can't UAT into it anymore. So it's this combination of like known state plus the other thing you're pointing at, dedicated hardware. This combination creates a bottleneck in the organization. If they were doing some of the stuff that I think you and I have been talking about, kind of infrastructure as a service and platform as a service, right? So we can decide what that means in a minute. But you would never ask, can I get into the UAT environment? You would say, give me a UAT environment. You would use it, and then it would like evaporate when you were done because it would be built from scratch each time, every time you wanted to use it. And therefore, as long as you had, some sort of way of having a dynamic infrastructure, also you could have at least 2 or 3 running at a time, or if you wanted to go to the cloud and you had enough money, as many UAT environments as you can imagine. And this seems to like be completely missed by so many organizations where they're still doing this kind of non-ephemeral. I mean, the way that we've said it in the past is they have too many pets, not enough cattle. But anyway.
Actually, I want to read back to the most recent. Was it O'Reilly was before me? I believe you guys talked about you your studies in sociotechnical, his in socioeconomic.
Yep.
I want to point out, like, I will reference a lot of Google books. By the way, I don't work for Google. I haven't worked for Google. One day, maybe, hopefully I can work for Google, but like, I'm a fanboy because I love how they've written things that, like, in retrospect, they talk about what they learned and the decisions they made.
Yep.
And so that's why I reference a lot of their books. But like, Jabe, that right there, not the technical, but the socio aspect of testing software.
Yep.
When you read the book, How Google Tests Software, one thing they'll get through is they're like, at Google's scale, you can't have a UAT. That's too expensive.
Yep.
And so as you get closer to production, what you're doing is you're modeling and simulating production-like loads and production-like traffic, but you never 100% replicate it. And so what you're getting at, especially around automated testing in this area, is why ephemeral infrastructure? I'd argue a lot of people are still stuck on this when they think about these manual tests, and still some people do automated testing, but nobody's thinking about it from these perspectives. And so I would argue you're absolutely right. Like, still a lot of people don't even need Kubernetes for that because they're still stuck at manual and they haven't even got to that level of being able to redestroy, recreate, and or create it from a flawed perspective. Like, imagine if you you created a new environment, but decreased your bandwidth by 50% to see how it would respond, right? And so you're gonna start doing some sensitivity analysis. Yes, like it's that's like the fact you have ephemeral environments is an outcome of a function of we need to work in this certain way. I'm like, I think we're probably for a lot of the religious listeners here, like they're going to be like, yeah, we completely understand that one. But like, what's the ways we work, right? And so you look at like Kubernetes was, I don't need to have this per team stack anymore. It's just there when I need it. We call the cloud now. And you think about like, you're talking about testing, like there's no such thing as a UAT environment. There's production and that's it. Like, there's production, and then there's a modeling, there's a simulation of production loads on my software, and then I put it in, and then I monitor what happens in production, and I have a clear rollback. It changes the behaviors. Stop right there.
Yeah, I think that's right. I mean, I think the other thing, at least, and I think this is a function of scale, right? I don't think everybody can necessarily do this, but one of the things I think you see when you look at Facebook and Google and some of these other organizations is that very quickly, because of their scale, they figure out we cannot kind of like guess at what people will do. There's just too many things of what people will do to our software. And I guess you could run like some sort of fuzzing algorithm against it or something like that. But it means that like it's not that you're testing in production because you didn't test before. It's that you're testing in production because you've tested all of the low-hanging fruit already, and now the only way to find the rest of the defects is in production. Like, you have to just kind of like let people do things with it because you can't predict what people will do with it. And this again, a little bit referencing back to Barry, right? Like, you can try to guess at all the stressors that are going to go on the system, but you can't actually know beforehand what they will be. You can only guess.
Well, and like a Google scale, like this, I want to put this point out. We're talking about the Google scale, and there's a lot of people. I love how Clay Schaefer talks about like the elephant-sized ant, right? There's my argument for why people also need platforms is they don't have the scale and scope problem. And so, actually, one of the listeners on here today looks like Susan talk about standardizing virtual reactions and value co-creation. I would argue at the scale of some of these big companies that we're talking about, the FANGs, that is how they get over the hurdle to scale. But to your point, in these small companies, that doesn't like that type of scale doesn't exist. But to your point, I can test deterministically around my boundaries. But what I can't test is the third and fourth order effects of what mine does to some other part of the system I may be unaware of. So to your point, you're right. I can't recreate that. But what I can do is I can react to it, though. I can monitor, I can measure, and I can create a probabilistic model. So the whole idea is you should be deterministic getting into production. But then you're probabilistically looking at as I've made this change, what's the probability that I have created a third and fourth order effect in the system? And then, quickly, can I associate that to me as a root cause or, one of the weaker links?
I guess the thing to point out there, like to be overly blunt about this, is that it means that things like observability in production become critical for actually understanding what's happening in the system, right? And health means something in production, right? Like, what should the system look like if it's healthy? Do we know what, like, how much CPU should it be using? How, like, what do we think is happening? So like, you know, I've worked with people at some of these larger organizations where they will say things like, if we deploy something into production and it takes up twice as much CPU as the last version, we'll roll it back until we can figure out why it's consuming so much more CPU. This, of course, means A, that you have a baseline, you have some sort of understanding what the normal is, and that you're actually measuring and looking at the deltas, right? Which I think, again, just in so many organizations, we don't see that type of stuff happening.
I mean, look at the basis of the SRE pyramid. It's monitoring, and like as your message come from. You're right. No, a lot of people monitor. It's optimism and rhetoric based. It's not deterministic. And you're absolutely right. Like, what does it mean? The biggest thing is like, if I've doubled my memory or my CPU usage, does it necessarily mean it's bad? I don't know. Maybe I restructured it such that was the intended outcome. But to your point, like there is that methodical, and it gets back to, actually, it was a conversation I had with Clay Schaefer one time. I remember talking to him. I was like, you know, I look at this, and he said something that was very apocryphal. I remember it. Like, all you all, like, God, I miss working with you all. Like, you are the most intellectually stimulating people I've ever come across. But anyways, enough of the gloating. You point out, is like, you look at like the management of these large companies. They are engineers by trade. They understand, like, they may not be hands-on technologists in the past 18, 24, maybe 5 years, but they understand how to call BS on an engineering approach. Look at most of your other companies that are non-FANG that are getting to scale and possibly scope problems around technology. They are arguably not engineering driven nor led by engineering talent or anybody has engineering management capability. And so I think what you're seeing right there, this gets back to your sociotechnical and socioeconomic, like the actual the social system of that organization is not driven by engineering principles or approaches. And that's why I hate to use the word software engineer. I'm starting to use the word software mechanic. That's what it is. Like, when somebody says they're a Java engineer, it's like, oh, you work on the core Java, JVM framework. Oh no, I just know how to write in Java. Spring engineering, that kind of stuff. Like, you're a mechanic. And I say that wholeheartedly. Like, I've started my career in AUS, and parts of my career, I'm just a freaking mechanic.
Sometimes I used to think of it as like being a plumber, because all I was doing was connecting endpoints to each other, inputs and outputs, without like really understanding what was happening down, or actively not caring about what was happening in some of the libraries, because the whole point was, I don't have to figure this part of the problem out, right? So I think, like, one of the things that I would kind of like, I'd also like think about in your, do you need a platform, or even anti-platform theory, is this idea that I call incremental elaboration, right? And so incremental elaboration is this idea that not only is there like a series of steps to an endpoint, but that each step causes a problem that will need to be solved by the next step, right? And so the really simple way of saying this, for instance, is you go to a client and they say that they're about to adopt Kubernetes. And you go, oh, that's interesting. That's cool. How many containers do you currently have? And they say none or few. I'm like, okay, so it's going to be really hard for you to adopt Kubernetes. And they say, what do you mean? Like, well, you don't have the problem that Kubernetes solves. The problem Kubernetes solves is orchestrating a lot of containers. You don't have a lot of containers to orchestrate. Therefore, like, you're jumping ahead, and you're trying to figure out how to build quality against, you build quality, solve problems that you don't have yet. So here, let me suggest you do it a different way. Just teach everybody in your organization how to containerize stuff. Well, why? Oh, well, because if you containerize stuff, it has particular value, and you'll understand that value. And what do you mean? Well, I mean, what I mean is, it's really hard to share VMs among developers. They're big. You check them in, they take up a bunch of space. Like, they're hard to move around. If you go home and download them on your home machine, it takes an hour and a half to download them because they're so big. Containers, on the other hand, are just little tiny descriptors of how to instantiate something. And you can check them in the source code repository easily and share them amongst your friends and in this system. And so that's good, because it starts your developers to start thinking about this idea of known state environments and things like that. They can start thinking through that. Great. But also it means that your developers will suddenly have access to as close to what production will be as they can get.
Yes.
And so they won't have this weird drift problem of like it works on my machine, but it doesn't work in production. Now, I'm not saying 100% that's true, but it significantly reduces those amount of defects. And you don't need Kubernetes to get any of that value. And also for most developers, that's where the developer value is right there. That's it. That's what they need. Now, Kubernetes is a secondary problem because Kubernetes is more like I have a bunch of containers now and they're talking to each other and I need to secure them and create a service mesh. Like there's all these other qualities that only need to be true if you have a bunch of containers already.
You just built out my straw man argument for Kubernetes.
Yeah.
Like this is why, like in my quote today, I talked about developer platforms being somewhere between a red herring and a straw man argument, right? So I think like besides missing the point when somebody doesn't realize what they're arguing about, and the fact that you have sort of a large sort of distorted point, I think you pointed that out. And like I love Kubernetes, I love the orchestration problem, right? But like as you point out, an existing organization, like you don't have an orchestration problem.
That's right.
Because you don't have the fundamentals to have an orchestration problem. And so now what you've done is you've just basically, with the saying we need to bring Kubernetes in, you basically, especially for the platform thing, you've distorted the reality of what your problem is.
Right. And I also think, like, to me, one of the things that this kind of framing does is if you have an end state in mind, we want to be running everything in Kubernetes. The normal way of thinking about that is to just go as fast as possible to get everything into Kubernetes, because then you're in your end state and you've like taken as little time as possible. And I think there's all sorts of problems with that. It causes all sorts of problems and a lot of rework in general. Again, because you don't understand why you're doing it and you can't close the feedback loop of understanding whether it solved the problem because you don't have the problem yet. On the other hand, if you take a kind of like each phase creates a problem, then you have this weird thing where you can say, okay, we don't move to the next phase until we have the problem that phase would solve. So it actually means that you don't rush to the end. You rush towards how quickly can we get to a state in which a certain kind of problem will occur, because then we can start adopting the next kind of technology. And, we can plan ahead a little bit, but we don't have to. Yeah.
Like you're stealing my argument for why not platform,
right?
Like I'm just letting you go because like basically I'm going to take this recording and I'm going to steal every word from you and I'm going to attribute it back to it. Because like what you're talking about to the platform, when people jump into the developer platforms, like I think back in my days when when I was the director of EA at Pods, the moving and storage company, we built a PaaS, but you know really what it was? It was just it was Console Connect. And it was GitLab. And we had some container, we were building containers. And so we had to have a place. They had just Microsoft servers at that point in time. So it's a Linux server. So we decided to containerize, but it wasn't large orchestration. It was very simple. And at that point in time, really what we did talk about what was our business value was like an engineer took a template and we use Spring Boot to lock down exactly the constraints of how we're gonna write the software, and to basically use that to deploy it. So when you look at that, like it wasn't like this broad thing there. Our problem was like we just needed to be able to consistently get to production quickly in a standardized route. And like when people talk about platforms, what you're talking, where I'm going to steal where you're going here is like the platform people are all these tools together, we got all this and all this kind of stuff. And it's really like, what is the real business problem? Is it? And I ask people like, if you get a developer platform, is it going to reduce the amount of time from commit to production? No, it's probably the same tool, same thing. You just introduced new geeky things and probably spent a couple $1 million doing it. And this is where I'll get off my thing on governance engineering, like in the highly regulated organizations, because like I'll argue today, the developer experience is not the bottleneck in most organizations. I'm not going to say most organizations don't have a bottleneck with developers, but the developer experience is not the bottleneck. And when I and I've been talking recently about the development experience, because everybody around software delivery has been focused on the developer. Now I'll argue they deliver a lot of the value, but there is a large value chain there with other people in there that
Yeah.
can completely obstruct the value they deliver.
Yeah.
Not intentionally, but just by design of the other systems that they're integrating with. And so there's the development system, not the developer platform. And so when I start thinking about this at a broader, you talk about the next problem to solve, I think developer platforms are not the problem to solve in most organizations. It's what part of the value chain do we bring into our traditional development process? And we start to do what we did between dev and ops with, you name your buzzwords, security, audit, compliance, all those people. But you're right. What's the next problem? And I think part of it too is like when you look at it, and I'm guilty of this, like we focus on, like there's the blinders. Like I'm an engineer, I'm in technology focused. I'm focused on what's my next problem, not what's the system's next problem, and system broadly speaking. And I think the developer platforms are, I mean, maybe some people will bat me, will come criticize me for this, but I'd go to town, I'd say it. I'd argue most organizations, developer platforms are still narrowly focused on developers and ignoring a large system. And I would argue in retrospect that somebody spent their $2 million a day, give it 24 months and look back and actually be like, did that really solve a problem? And I will put money on it doesn't, because there's no systemic analysis of development.
And I think like, again, and we can talk, I like this kind of point that you're making about what is in the system on the way to deployment. What should you actually be considering? Like, because the answer I think is interesting for a lot of people to think about. It's because like I know organizations have perfectly good CI/CD practices, but that doesn't mean they can deploy fast because there's other problems, right? And so I think one of the things when I think about this, when I kind of try to get people to understand this kind of like there's a problem, there's a next problem thing, it's basic, it's like basic theory of constraints analysis with some predictability, right? And so like let me explain really quickly what I mean. So like let's say, what is the problem that Agile's trying to solve? And I mean, there's all sorts of different answers to that, but I would argue the primary kind of constraint that Agile is trying to remove is the product team, the product people, their cycle time for releasing in order to react to the environment that they're in has a shorter cycle time than the developers are able to perform in. So in other words, these people want to go faster than these people can currently go. So that's your bottleneck. Development is the bottleneck for the product owners, right? And so if we can balance that out, right, we get the developers to be capable of developing features in the time frame that the product owners need to react to the market, then we're agile. That's basically what agile means, that the developers can go as fast as the product people need them to go in order to react to the environment, right? That's agility. Well, what happens then? Well, all of these developers, they were working with operating people, and those operating people, the people who were operators, were used to the old cycle time of the deployment the developers were working on. So they were in the 90s and the early 2000s, they were used to getting new software packages to deploy every year, to every 6 months to every year, right? Like that's the cycle time. And so are the practices for deploying software into production the same at 6 months as they are at 2 weeks? No, they're not. So that's the new bottleneck, right? Now, I think the thing that I think we should poke at a little bit, because I think some of your ideas are good for poking at this, is that what happens when you balance the cycle time between development and operations by doing a DevOps transformation? Like, where does the bottleneck go? And I think that the bottleneck goes in pretty predictable places. So, beforehand, we were talking a little bit about this idea of manufacturing engineering. And I think that we can kind of like frame this, where's the bottleneck moved in the way that a manufacturing engineer might think about it. So like let's start with like, what is manufacturing engineering, or what is a manufacturer engineer?
So you think about a manufacturing engineer and sort of a traditional hard goods, they're there to design and develop how you integrate to production of a good. So let's say a chair, or a car, and they look to balance quality and economics. So this is an individual that's looking for the system to go from, okay, as I bring in my raw materials, how am I getting from raw to a quality product within a set of economic bounds? How does that affect it, not just internally, but by what we can do, but also external demand? And what's that going to do to my system? And when you start to think about DevOps and platform, and I look at this, like really what a manufacturing engineer does for hard goods, your developers, I would say your platform engineers, what the people call themselves platform engineers, are doing for software. Right. And what I really see as I look at this, the more way that people operate, even outside the words they use, they're really designing the software manufacturing. I know some people freaking hate that term and hate when I say software manufacturing, but at the end of the day, that's what they're doing. And so I think that instead of looking at platforms, like platforms is the tail wagging the dog from a software manufacturing perspective, in my opinion. Thinking about it from a more manufacturing engineering, saying economically, because I've never heard anybody talk about the economics of platforms besides certain people and vendors screaming from the rooftop that it saves money. But everybody did that with Kubernetes, and everybody will do that with any new technology because that's what marketing and sales does. So I'll stop on that rant right there.
I mean, so there's a couple of things that I think about. Like, so one of the things I might immediately think about is that the argument from efficiency, kind of reduction of something in order to create more value. So what part of what a manufacturing person might be doing, although we can definitely talk about another version in a second, but like the argument from efficiency goes back to the do you have the problem part of the question, right? So again, you could probably create efficiencies with Kubernetes if you have the problem that Kubernetes solves. On the other hand, if you don't have the problem that Kubernetes solves, implementing it will not make you more efficient. It will make you less efficient, right?
Well, can I interrupt it? Like, there's one E word that a lot of people refuse to use, and they always use efficiency instead of it. What E word do you think that is?
Effectiveness?
Yes! Like, when can you ever be efficient before you're effective?
No, I mean, you can't, right? I mean, this is one of my favorite kind of Deming things that he talks about. Deming says there's an equation. The cost of a thing is a relationship between the value that's produced and the cost it takes to produce it. And that gives you an idea of how much value is created because you subtract the two, right? And his argument basically is this. Value is a property of what you produce. And cost is not actually a value that most people care about if the value isn't high enough. So like very low cost things that don't have the values that people want or the qualities that they want don't sell very well. And so his argument is basically this. If you focus on reducing cost, you almost certainly will reduce quality at the same time. It's like just the way the world works. If you spend less money and less time on something, it won't be as high quality. Quality has a cost, right? On the other hand, so it creates, in his idea, it creates a negative feedback loop, right? Like a feedback loop that causes negative outcomes. On the other hand, it says if you focus on value, effectiveness, by default, costs will go down. And the reason he thinks that is because if you get value correct, you have the money and time to improve the efficiency of the system, but B, you actually know what to develop as opposed to just like randomly developing stuff to reduce costs that doesn't create value. Anyway.
You nailed it. Like in my mind, like if anybody remembers Kmart, like this is the Walmart versus Kmart. Kmart was low cost. Walmart was cost optimization. Walmart knew exactly what they had to invest in to become more effective. And Kmart just tried to slash prices and put more blue lights in there. And we know which one won that war.
Yeah, exactly. So I think, so this is the other argument that you could make for this manufacturing engineering, which is increasing flow, right? So
Yes.
it's not that you're trying to. It's not that you're not trying to reduce efficiency. Maybe you are trying to create efficiencies too. But the other thing you could argue is that another form of value would be increasing flow, right? Like increasing the amount, the cycle
Yep.
effectiveness of your system and making it more responsive. Yeah.
I think you've hit it. The cycle effectiveness, absolutely. Increasing flow, and focusing on flow is focus on effectivity and
Yep.
efficacy,
Yep.
not efficiency.
Yep.
Because the question is, can I get the same good to the same place 100% of the time in the same with the same quality format?
Yep.
And like when you put those levels of constraints, that's effective, not efficient. Once I'm effective, now I can focus on manipulating one of those variables to some extent.
Yep. I agree. Yeah, because you can then kind of determine what variables are important in the marketplace that you're working in. Yeah.
Exactly.
Yeah. So so in this frame of like, how do we reduce, create efficiencies and or increase flow? What are some of the things that that you see now that need to be manufacturing engineered? I have two things that I think are the obvious problems that are happening post you doing some reasonable level of DevOps. What do you see?
Well, like with the name and then there, governance engineering, governance is the first thing.
Yeah.
And this is not going to be just for highly regulated companies. It's going to be a lot of companies. But governance is going to be my number one thing there.
Yeah.
And my number two is actually deprecation of software.
Interesting. Cool. Yeah.
Not a lot of people think about that. Think about getting it to production, but like once it's lived its life, how do you deprecate? And regardless of platform versus product, at some point in time you have to pull, and like, Google's good at this. Like they just did this the other day, Google Domains, like, yep, we're done with it. After 5 years, it was like 5 years in alpha. I loved it. And then all of a sudden it went GA, and like, it wasn't even a year later. They're but how do you deprecate products too? Because that's from a systematic and an economic perspective, like that's the business. What am I still in business of providing? But I think governance, man, I could have shared with you. What was the other one that you were thinking?
So I like your second one. How do you deprecate stuff? And I'm going to tell you the other one that I think it is, but it's probably related actually. But I saw this guy the other day, or he was talking about banks, and basically what he ends up saying is, has anybody told the IT managers at big banks that they're not curators at a museum? Which is like,
that is awesome.
Yeah,
I've never. Wow, chief, they are literally just a curator. Like, hell, if you think about half the people in some of these organizations, they're just there because of what they know, not because of what they can do.
100%. Yep. So I think that gets us to this idea in my mind of, so people will talk about composability of platforms, and they'll also maybe talk about having opinionated platforms, right? Well, both of which I don't necessarily disagree with. But I do think that there's this other idea that's important, and it has to do with, sometimes I refer to what you're talking about as autophagy, the ability to like redigest dying cells and kill them because they're not effective anymore. That's autophagy. So like if you do fasting, one of the things that happens in fasting is you increase the autophagy in your body. Your body goes and scavenges old cells for energy, which has a secondary benefit of you kill off a bunch of old cells so you can regenerate new cells. Anyway, so the thing that I think enables autophagy in this frame of like composable and opinionated is actually this weird other way of thinking about it, which is you need to build your system to be decomposable. In other words, it's not just that you build it so it can get glued together with super glue. In fact, what you need is the ability to compose something, and then also the ability and the design methods for building a way that you can unbundle it easily so that you can stick new stuff in, basically, right? So I just think it's worth kind of thinking through that a little bit. And then the second one that I had, which I think is very closely related to the decomposable question, is a lot of organizations that I see are having two big problems. One is your governance problem. So in other words, like I can deploy my code really quickly into production, but there's someone at the end of the line saying, you have to slow down. there's a process for this and you're breaking the rules, right? The second one, though, is architecture, right? Which is, okay, so like you've DevOps a bunch of stuff with the CI/CD pipeline and deployment stuff, but now just some of the stuff, it doesn't matter how good your CI/CD pipeline it just takes a long time to deploy it because it's really big, right? And because it's really big and the surface area is really big, you have a lot of people working on it, and therefore you get lots of combinatorial complexity and other stuff, which kind of reduces the effectiveness of deploying quickly. So I think architecture is the second big one that I see. Yeah.
Well, I'm going to go back to, for anybody who haven't listened to the O'Reilly one, like I love you talk about optionality, because there's some things I've talked about in sort of my seminal talk around governance engineering last year at the DevOps Enterprise Summit. I used basically the same like Bayesian theory, but binomial mathematics to price the options of future things. When you think about batching, it's really an options pricing. If I have 16 independent things and a 99% probability of them independently being successful, was at 0.99 times 16 and then 1 minus that, and your probability of success is basically like 1 and 2 at this point in time. And it's like what I loved about you talking was the optionality, and actually what you just talked about, the autophagy. Autophagy. About the autophagy is like, I don't want to use the word decomposition, but decomposable. Like the ability to get down to like my options for like paths like have been reduced. Like I don't necessarily want to increase the usage. I want to decrease where and how it's being used, such that I can be more mathematical. Because like you think about cyclomatic complexity, and I was actually talking with a couple of folks the other day, working with some folks out of the UK, a couple of places around governance, and like like there's companies looking for, like a lot of companies don't have insurance for cybersecurity, and a lot of insurers won't provide it. And the reason why is like there's not an easy way to give like a 1 to 10 rating. And if you get back to what you're talking about when autophagy is because people have built these non-composable systems, and every company goes in, it's literally such a unique snowflake. And when you think about the concept of cyclomatic complexity and the probability of these alternatives, like the optionality of it, like at the end of the day, the probability of success is always going to be lower than 1 and 2, because of just like, even if each individual connection is 99%, let's just give it 4 nines at the end of the day, like you still, because of all the connections, have significantly reduced the probability of success. And so like I love where you're going from, because like when you think about platforms, and like some people think about platforms are like constraints, and actually Susan, you talked about like standardization of virtual interactions, like, and this is the idea of enabling constraints too. Like how do you start to reduce? And I love about the architecture, because the architecture, as I think about it, is just that focus on what are we not going to do. It's not what are we going to do, but what are we not going to do? And I think nobody asked themselves that question. And if they did, half people wouldn't end up with Kubernetes.
I think that's right. I mean, and I, like one of the reasons I like this word decomposable, right, is because autophagy and other terms for removing things is kind of like saying you need to be able to kill things, and dead things decompose. So it's like it's a nice little poetic play on words that I like too. Anyway.
But what I like about it is, like, as you said, that there was some reading it later, like we think about complex systems. Systems become complex because we think we always need to add something. We have a bias towards action.
Absolutely, yeah.
And like the autophagy, I'm always going to, I'm not going to, I'm one of these days, autophagy. Like with autophagy, it's actually focusing you not to have a bias towards action. You have to sit and wait and be like, hold on a second. The action we're going to take is not to add something, but is to ask, should we be removing? And that's where actually when people talk about platform engineering and some of this stuff, like I hate the word platform. That's why I talk about developer productivity. Actually, when I did my research, a lot of your FANGs and people will call it developer productivity, not platforms. And that started around 2017 based upon like, as I could find around. And like, that's really asking the question, what don't we need? And this gets back to like the the individual versus the collective interest. Like right now, a lot of these organizations have resume driven architectures because of the individual interest of the individuals, of the architects, of the people putting it together, not because of the collective business interest of the company.
Yeah. So I think, I think it's interesting to think through some of those ideas of like decomposability. The other thing I wanted to point out or talk about just really quickly so you were using this term manufacturing engineering, which I think is interesting. And the way I was imagining that in my head, or the way that I've thought about that in the past, is it's to be overly blunt and probably reductive. It's like the people who are manufacturing the pipeline to get stuff to production, including things like architectural approvals and engineering approvals and security and compliance things. And so I think that's interesting. But I wanted to point out that like there's another idea that I've always been a fan of, and I think it's part of. I want to kind of point it out as a DevOps-y way of thinking about it, which I mean, to me, manufacturing engineering feels a lot like something that the operators do, right? They build these kind of systems for deployment and stuff like that. There's another term that Toyota likes to use and some other organizations use to describe it from a slightly different perspective. And the term is design for production or design for manufacture. And what they mean by that is it becomes the responsibility of the team designing the thing to make it in a way that can be manufactured, right? So like I like to say in that frame, we can't just improve the operations side. We actually have to teach the developers how to design for operation. In other words, are you considering how your code could be more or less operable, and are you improving the design to make it more operable, right? And what would be entailed in that? Because that, to me, then if you combine those two things, you get I have a smooth flow into production, but what's in production is actually operable, as opposed to I have a smooth flow of production, which means I can deploy more inoperable code quicker.
So SRE, I think about this. This is actually some stuff I'll talk here in a bit about governance engineering. Like, I would argue yes and no. When I say no, this is where I get a software engineer versus software mechanic. Yeah. Okay.
Yep.
The mechanics, the people that are like, I just do Java, I just do Angular, I just do that, like, pull them out of this equation. Yep. There's a whole other problem with that to begin with. There's a whole other trade-off. I don't want to say problem. Like, I've used mechanics myself for great cost. You got to figure out how to use them. This comes back into the software engineering. So like the design for manufacturing and manufacturability, I liked it as a key concept. The question I asked from the social system is like, how do you bake that in? And like, we think of like architects, like the traditional EA was sort of like that. Mm-hmm. And I hate using like enterprise architect, like I there was for the longest time, like I was struck to the term architect. I loved it. But at the end of the day, like to your point, like I think there's a party that they're helping to design for something to be manufacturable or deliverable. Yep. They are defining constraints. Maybe they're recombining those constraints into something. Yep. But to your point, but I also would say, like, I would argue that this is where I bifurcate between the software engineer and the software mechanic. Yep. For the organizations listening, ask yourself: is it an engineer? And this we probably get rid of the word architect and just talk about architecture as something we do, as opposed to an architect. Because like if you look at was it architect comes from Greek, the master builder. Yep. So like as you look at yourself, say, okay, stick I'm this Java, Angular, whatever it is over here to the right-hand side, like they're just going to receive the stuff to do. But like you have this now little mesh between, like you're talking about, like maybe it is a software manufacturing engineer. Maybe it's just like you're meshing this stuff together, how to build it for manufacturability. And the one thing we're talking is, you said one thing a couple of days ago when we were talking about product versus product lines. And like, you know, as you think about it, like a manufacturing assembly line, there's not a generic one meets all in these organizations. If I'm creating a Ford Taurus or a Chevy Cruze, I've got a manufacturing line that's designed to be effective and optimized for the trade-offs of that product.
Absolutely.
And its product variations. And you said something I don't think a lot of people are thinking about that I've taken to heart was, how do you look at, like, from your software products, from product variations? Because a lot of platform people believe there's just like one pipeline to rule them all. We know it's not. But once you start thinking about it from a product family perspective, as we start to get into complexities and interactions, that right there just completely reduces the scope of interactions and sort of narrows that perspective on what problem am I trying to solve. I'm not trying to solve a one pipeline that fits it all across the Fortune 50 company. What I'm trying to do is decompose. Let's do the autophagy. Like, I'm now trying to decompose what the business, the product functioning is of our organization, and then become effective for individual product families in that way. So
I think so. Like, I think again, to like play with what you're talking about, and both decomposability and a little bit of complexity theory. Let's take your CI/CD pipeline. I think that most organizations are trying to build one golden path theories, right? Like, this is the way to deploy. We can deploy this way. And I suspect that in most organizations, maybe 60 to 80% of the software could just go down the golden path, and it's perfectly fine. There won't be any impact. The problem is that I think in most organizations, there's going to be stuff that is not going to work. 20% is not going to work on the golden path. Now, there's two ways to think about solving that problem. The way that most people solve that problem is you build a completely different pipeline in a completely different way for the things that are in the 20%. Like, maybe you have 10 other ones because whatever. That's one way of thinking about it. Increasing the amount of completely unique pipelines from end to end, right? If you take the decomposability theory of the pipeline, though, what you would say is, okay, great. So your thing doesn't work. Can we figure out what parts of the golden path don't work for you? And because we built the golden path to be decomposable, we can take those parts out of the golden path and stick new things in. But maybe you could still use 50% of the pipeline. Maybe you could use 70% of the pipeline, whatever. Because what we should be asking is, what needs to be modified about the golden path specifically for your product? Not the opposite way, which is, we're going to use a cudgel to force everyone to use the golden path, which means we will tell people you cannot modify it, which seems to be maybe a bad idea. I could be wrong. I don't know.
Well, hold on. Like, what you're talking about, I've talked about this before, and I always go back to Dell computers. What you're talking about is mass customization.
That's right.
And so this is where I get, like, this is product versus platform, and like mass customization, like the computer, like I don't have the accurate numbers, but if you read back of some of the Dell, like what made Dell good, well, the mass customization, the computer had basically 13 to 15 parts, but 13 to 15 factorial unique parts, they're different combinations. You get 3 million potential outcomes. And so all they had to manage was a supply chain of 13 to 15 components.
Okay.
And you get this mass customization. And to your point, that's where I go. Like, I would argue in most of these CIs, the build, the testing, and the deployment are the only three things that will generally change. Everything in between, I would argue, stays the same. And so to your point, it's like, okay, now let's bring this, like, we have this one pipeline that could probably fit for 80% of stuff. But this other 20%, what other product families are there? Do I have some type of true legacy application that makes no business sense to do anything with? Do I have an IoT-based app that is completely different than just throwing something up in AWS or on Kubernetes or whatever it is? And you're absolutely right. It's like looking at that and saying, okay, how do I mass customize this? And that's where I get back to the manufacturing engineering. Like, the software manufacturing engineer should be asking those questions and driving the organization to those outcomes. And if they do it well enough, this gets back to some of the GORAT theory of constraint. Like, this is the mafia offer. If they do it well enough, they're going to provide an offer that their internal people cannot refuse. They literally will not want to use anything else besides that, because it fundamentally changes the way they operate for the good.
That's right. Absolutely. Yeah. And I love, the thing that I love about thinking about the mafia offer internally is that it's an offer, right? So, like, you have to explain the value of the thing you're doing in a way that the person you're asking to use it would value it, right? So what I mean by that, we can go back to the effectiveness versus efficiency arguments and stuff like that. Most organizations, the IT department or the kind of the ops department, are paid to make things more efficient. That's what they get paid for. Do the same thing over and over and over again. Reduce the cost of doing that same thing over and over and over again. For instance, we need to deploy this software every day, twice a day. So you're going to be doing that a lot. If you go to your development team or your product owner and you say to your product owner, you need to use this platform, and they say, why? And you say, because it will increase efficiency and make my life easier. They'll be like, right, I don't care. I don't care about that. I don't get rewarded for that. I'm not compensated for making your life easier. I'm not compensated for, you know what I am compensated for? Putting new features into the market. And so your thing that you want me to do is going to reduce the amount that I can do the thing that I'm rewarded for. You can imagine that the mafia offer inverts that. It goes to them and it says to them, let's be really clear. If you use this platform or CI/CD pipeline or whatever, it will increase just your ability, like reduce your cycle time, so you can just put things in the market faster because we've designed it to be really fast. But B, you won't have to pay to operate and maintain it because somebody else is already doing that. So you're going to reduce your cost. So your developers won't be doing stuff that we're already doing. So it's going to reduce your cost, your cost. And what I mean by that is it's going to free up the developers you currently have doing these things so that they can increase the amount of features that you're deploying. Wouldn't that be better, Mr. Product Owner, like Mrs. Product Owner? And that's the difference between those pitches. And I think it's really critical that people think through that. And therefore, it means they have to go talk to their product owners and say, like, what are you trying to achieve? What are you trying to get to? Why are you doing this?
So you've nailed it. Some of the governance stuff I'm doing, I've had the opportunity to exchange with a couple technical folks that have found themselves in this role. Mm-hmm. And the thing about this, you talk about mafia offers, like, you're right, internally you have to do this, but there's a lot of technical people that don't want to do it. Yeah. And it's a true product approach, and nobody's hiring product people internally to build like internal stuff. So this tends to be an emergent phenomenon. Yep. But yeah, you've nailed it. Like, you have to turn on his head. It's like, don't do this for me. You have to create the offer for them, right. Yep. Which means you have to have a broad, and you have to go out and you have to ask people. And it gets back to, like, when you're doing this, you're really building an internal product at the end of the day, and you have to treat it like a product.
Yep. And I think the other thing from a complexity theory thing, it's metastable. And what I mean by that is that you can't just solve for the needs of your product owners. You have to solve for the needs of your infrastructure people and your needs, right? So in other words, you can't go to the IT organization, the central IT organization, the kind of infrastructure people, and go, listen, we have to increase the complexity of your deployment because those people want X, Y, and Z, right? You actually have to balance these things, right? It's like, okay, so you want this, and this is what we need. All right, this is the metastable system. This is the sweet point that kind of is between those two things, right? So I don't know. I think that's part of it. We talked about automated governance briefly, but like for those people who are innocent, can you disabuse them of their innocence? Can you tell them what is automated governance? Why is it important?
Well, so I'm going to define it by actually defining governance first. So, like, automating governance, at the end of the day, you can just put those two together. It's the automation of your governance processes. Cool. But I love Susan's words here. She asked, what is the definition of governance? And I clearly define it as proving you're doing what you say you're going to do. Right. So there's two things to governance. One, something that explicitly says what you're going to do. And then there's a second thing that's a proof that you've done it for as many instances as you've repeated whatever the process is. And so the whole fact of automating, when I talk about automating governance, I'm not necessarily automating describing how you do it. That tends to be the manual creative process. I'm talking about automating the proving that you did what you stated you're doing. So when we talk about automated governance, that's what automated governance is focused on.
Yeah. So sometimes I get like, just as a quick side note, so that we can close two things together a bit. I get really pissy at people who are like worried about control, being, like control, and this theory that there's an illusion of control, right? So I get a little bit pissy about this because I think that they're confusing a couple things. So control theory from manufacturing and from the military and things like this is much more like what you're talking about governance. It basically says, I believe that the system should be doing this, and I'm in control if it's doing what I expected it to do within a certain range, and I'm out of control if it's not in that range, right? If it's outside that range. That's basic control theory. You can go back to statistical process control and all those other kinds of ideas, right? And in that way, like, do you want to not be in control? Is like, clearly being in control seems better than not being in control. Or do you not want to know if you're in control, right? Which is different than saying, I want to treat the system as completely deterministic and therefore something that I can always be in control of, right? Which is not what we're saying, right? Like, we're not saying that. What we're saying is we assume there's some wiggling in the system, and we just want to know if we wiggled out of the range that we need to be successful. And therefore, the governance is about staying in control, which is does not comment on the underlying system becoming more deterministic. It just comments on, do we know if we've wiggled out of the control variable, right?
I love it. I mean, I love how you stay there. Like, yes, it is variability. How does our system responding to the variability, the nature of variability, and where it's being of its environment? Because, like you talked about, the state, like in a system, like we start thinking about, there's the system itself, which is the system technically could be deterministic, but there's the environment in which it operates, which is you think back to right, that's non-deterministic stuff. And so, like, what determines whether your system is controllable or in control? It's basically how it's fitting within its environment. Now, if its environment changes, then actually the determination it can control. Like today, I could have a system that is compliant. Tomorrow, a new expectation comes out, and now I'm woefully non-compliant. Like, let's talk about Log4j. Up until yesterday, I was good. Now today, there's an exploit, and I'm completely not good. And I think the ability to respond to that, like as you point, like not having the control, like tight neck choke somebody, but having the ability to react to the change of the environment and like react as instantaneously as possible. I just basically, like, could you make it under 10 minutes? Could you make a change to your whole system? Like, so I love how you put it. That's the illusion of control. There's like control theory, and there's the illusion of control, and like your juxtaposition was great.
Yeah, and I think so. Like, there's a couple of things that it kind of makes me think about. So one of the arguments that I think Agilists would make, and certainly some DevOps people would make, would be you have to reimagine risk, right? And what I mean by that is that in kind of old school 6-month cycles, 12-month cycles, part of the reason it took so long was because you were basically trying to reduce the likelihood of an error happening in production as close to zero as possible, right? And, this again, it ends up being one of those Pareto rules, right? Like the first 80% of the reduction of risk is pretty cheap. The last 20% takes a lot of time and a lot of money. And so if you're doing that method of like fail-safing the system, trying to make it so that it won't fail, that's one way to think about risk. Another way of thinking about risk, which I think is more popular in the Agile and the DevOps communities, is to say the way to reduce risk is to increase your ability to respond to the event of something going wrong. Why? You should assume something's going to go wrong. That's the safest opinion. You shouldn't go into a system where you think nothing will go wrong because we checked it enough, right? So again, like governance to me now has like different flavors. So like I think, and you can tell me if you think differently, but like change review board feels like very old school version of how to do this. It's the risk mitigation of trying to convince yourself that you could remove all of the likelihoods, as opposed to, I assume, something like automated governance, which is more about reducing the cycle time of governance so that it happens more frequently, so that we can reduce risk by being more responsive to the failure.
You've nailed it. It's exactly like the change. I mean, at the end of the day, I always call change boards just the political approach to risk management. At the end of the day, it's easy to fire somebody if something goes wrong, but not fundamentally change it. So to your point, it's like, how do you reduce the time between identification and resolution? But also, like, a lot of this isn't real time. So like, can you constantly, like, what if you could run your governance process in real time? Like the epitome of a governance process is a real time governance process. Like, let's look at our own, like, let's look at governance here in the US. Like you have a police who are out there on the streets and they're there to respond. They are patrolling, so they may see something as it happens, but also they're out there. There's capacity to respond as necessary. And so like, how do you build that concept of internal policing in without basically asking for permission? Because nobody goes to a board at the city level and says, hey, I'm going to rob a bank. Is that okay? Like, I think like change board is like, ultimately somebody's asked like, yeah, I know I'm not supposed to do this, but I'm going to go do this anyways. And if you don't say yes, I'm going to go take the political approach, get my VP to tell your VP. And then like, we know how it's going to end. But yeah, like how could you, and you think about risk, right? It's like the issue over time. There's always going to be an issue. There's a risk that something's going to happen, an issue happen, but the exposure of that issue over a period of time is really like, what are we trying to solve for? And it gets back to the talk about Kubernetes. What are we trying to solve for with governance? We know something's going to happen. What we want to solve for is like, for the known things, do we have preventative measures? Can we prove those are in place, right? And can we keep those in there? But for the unknowns, how do we, once that happened, we reduce that time to recovery, the time to resolution, such that we've, reduced any negative impact, potential negative impact.
So I think like sometimes I try to think through this and the automated governance by kind of doing like an analog. And so the analog that I try to do is when I was a baby engineer, or what were we calling ourselves? A baby mechanic.
Software mechanic.
Baby software mechanic. I worked with one of the very biggest of the auction sites at the time, eBay. And at the time they had what was called an E10,000. And so an E10,000 was the largest mainframe that Sun sold. It was massively redundant. So like it had on three sides, there were completely separate ports. So you could have like three different NICs come into it. And then inside there were multiple motherboards that were hooked together so that if one of the motherboards went down, there were still other motherboards in there, right? So you get all this kind of stuff. And this is a change review board machine. In other words, it's built on the theory that we've made it so redundant that you can assume it won't fail. That's what the goal was with it, right? And of course, there's a couple problems with it. One is that sometimes it does fail because sometimes like whatever, the power supply goes out and also your generator's down. Like there's all sorts of kind of failure possibilities. But the second one is that there's a limit to the amount of capacity that one machine has, even if it's a very, very big machine. So there's like there's a scaling problem and then there's a risk problem, right? And so I like to compare that against what Google did. So Google gets to a point where they need to deploy a lot of resource. And it's my understanding that they actually considered using a big mainframe like an E10,000. But what they did was they did something completely different. They said, no, what we're going to do is we're going to use commodity hardware because it's easy to get our hands on. But it will require a thing. And so what's that thing? We're going to have to tell the developers, you need to develop the code in a way that assumes that the node that you're currently working on could fail at any point. that is a constraint on you now. You can't assume the system's going to be the underlying infrastructure is going to be there. It can sometimes disappear, the node you're on, because it's commodity software, hardware, and sometimes it's just going to randomly die. And of course, I think the result of this is that it creates an entirely different architectural paradigm, right? That leads us eventually to Borg and to containers and all this kind of stuff. So I think that form of risk mitigation had an impact on architecture and software engineering, whether people recognize how that happened or not. But what I think has happened is it's the DevOps story again, which is like the developers are going much faster now and the operators haven't caught up. It just happens to be what they haven't caught up with is governance being capable of thinking this new form of risk, right? That they need to say all the time, we shouldn't be trying to prevent all defects. We should try to prevent all reasonable levels of defects. We should try to figure out the 80% of them are removed, all that kind of stuff. But what we should do is we should be building a governance system that assumes shit is going to break.
Yes. It's going to assume that at any point in time, it can become non-compliant. Exactly.
That's right. And how do we know it's non-compliant? And how do we be responsive to that non-compliance, right? So I think then like we get this weird thing is like, to the extent that we can get people to start adopting these new governance methodologies, those also will then start impacting architecture again, right?
Yeah.
The way that we build the system will need to be built to be governable, right? And that what would governable be? I assume it has something to do with some sort of level of observability, some sort of level of componentization, so that you can replace subcomponents quickly. Like there's going to be a set of qualities that will determine whether the system is governable or not. Yeah.
I think you've nailed it. Like as we're getting into this, like there's a couple of things I'm working on around sort of a modern governance reference architecture. But to your point, like how do you build governable software? One thing I would argue is like at the end of the day, testable is like, what you're doing is like you think about governance. Governance is really just testing software for behavior and state. It's just a different state, a different type of behavior, but it's now becoming testable. So if you have that, not just because it's testable doesn't mean it's governable, but as you start to think about that, it's going to be this is where I talk about the 3 lines of defense. There's this thing called the second line. So the first line is like I set my software up like Jabe. You're like I'm going to have 2 people review my PRs. And so like you go to GitHub, you basically put the number 2 in there, and it can't go through without 2 people. That's the first line. The second line is validating that actually, like when you went through that time, there was actually 2 people in there. So what you're going to start to see is when you talk about governability of architectures, there's going to be these observability architectures built in, because that's the new problem. How do I observe not the state of my performance, such as my cores, my whatever it is, but this new behavior and state of the system? And generally, it may be at a component level, but it'll be at an aggregate. Because remember, I'll identify if the system's non-compliant, but from a decomposition perspective, and I need to go down to that one thing because I could have 99 components, but the one is non-compliant. So therefore the whole system's non-compliant. So how do you then forensically identify that? And I think that's what you're going to, that'd be my prediction as we get down to governability. It's going to be forms of testability and observability, but this sort of new domain concept that you have to figure out how these domain concepts of governance, compliance, and audit now overlap with the traditional technical domains.
And so again, so let's so we've been talking about risk and governance, which are good things. And so like what I end up kind of thinking about is like there's this new idea of risk that we have to kind of think through, and that impacts governance and blah blah blah. But also governance now becomes some form of real-time monitoring of the system. Like it's not a partial monitoring of the system, I guess. Or it's not a pre-monitoring, it's a in production monitoring of the governance capabilities. So I think that's roughly
Well, I think you've nailed it. Like in production, like you are monitoring the state of a system in production, like, and it could be different environments, but you're looking at like, I mean, I'm trying to think of an analogy, but if I'm constantly you know what, this is going to be sort of a weird, but like if people are building large buildings, there's going to be a surveyor that's like, they've got a permanent thing and they've always got a scope that's looking to make sure as you go up, everything's level. Like basically it's that same idea, but now you still have that scope there after it's been built to make sure that it's constantly level over time. So you don't get a leaning tower of Pisa or whatever happened to that building in San Francisco or New York when it's falling apart.
San Francisco,
yeah. So like as you're going through that, like I think that's what it is. Like it's a new form, it's a new perspective on how to monitor and observe. And it's not been traditionally done on a continuous basis. And so the new architectures are going to solve for this continuous observation problem of things that have never been observed before. And
so like I've heard this described once before. I think it was Eric Ries described it this way. He talking about IMU, and I think it was him. And he basically said that what they built was an immune system for their software. What he meant by that was when they deployed, they could determine that, going back to what we were talking about earlier, they had determined there were certain variables they were trying to optimize for. And so when they deployed, they would observe those things to determine whether or not the system had improved or not. And they would do that in production because the only way they could know the answer to do people like this is to monitor that. And the immune system basically was this idea that the system should be able to reject features, functions, patches that degrade its performance automatically. It should be able to get rid of them. Last thing-ish. You can talk about it if you want to, but definitely I want to make sure I get this in here too for people. So talk about governance, talk about risk, compliance. Like what? So like compliance officers are some of the best people, the favorite people for software engineers. Everybody loves their local compliance person, and definitely testers love compliance people. They think it's really awesome. Because who doesn't want to record everything with a video camera and or a screen capture device to prove that they've done some random thing that the compliance officer believes should be done? Seems reasonable. So what in this new frame, in this automated governance frame, how should we be thinking about compliance? And
so there, as you think about compliance, so there's a secure controls framework. It has secure controls framework is a form of common controls framework, but actually I'm going to see if I can present my screen here real quick.
Sure.
Share. Can it allow me to share a specific window? There we go. I want to show this real quick to everybody.
One second.
All right.
I think if we do this, shift, what is happening? Oh, I have to add to stream.
There we go. So what you're going to see here is, I call this as sort of your policy cake. I love this. There's a lot of things around the secure controls framework I love, but what I love about this most is this, and let's get down to compliance and the different perspective and domain. We misuse the word policy on the tech side. So policy is really just a high level statement of intent. Mm-hmm. What we think of on the tech side as policy is really what they call procedures, these very granularly defined practices. Mm-hmm. And so as we get to compliance, when you think about composability and decomposability and sort of aggregation of a system, what we need to start looking at doing is what are the actions? What are these small individual single purpose state validations I can do of my software, of my system, that in aggregate is, one could be a guideline that just basically says not mandatory, but I recommend. One could be a standard. So that's if this doesn't pass, the system's non-compliant. But then these roll into sort of this higher level that's a little bit below a high level intent, but these are things like your NIST 853, like your SOC 2 and that kind of stuff. Yep. These are formal compliance. And so as we start going down to compliance, like the idea, and I love how secure controls framework stays it, like compliance is there to evaluate security. So if you're secure, you should be compliant. And all compliance is like, we talk about your officers, they just want the proof that you're doing what you said they did. Now, in many instances, there's auditors like, well, I believe you should do more than this. I'm going to set that aside for a second. But I would also argue, and this is actually, I'm starting to get in a lot of rhetoric, and there's a couple cool things I've been playing with. One called Whitmore's chart. It's like how to chart an argument. I would almost argue compliance has become a big issue because nobody knows how to build the basis of an argument to show I'm meeting this control objective, which is generally what the industry's focused on. And so as we start to think through an architecture, one thing I'm working on, and there's something called NAPE, it stands for not another policy engine. But it's the idea of, can I define in a single sheet of paper a procedure that's fine-grained, that provides the context and ties this all together such that I can aggregate maybe 1,000 to 10,000 of those. So when somebody asks, am I meeting this NIST control objective, or are we compliant at a policy level for the system? The answer can be a yes or no. And if not, you have that graph capability, like you have that depth and breadth question capability to say, what specifically is it? And in broad strokes, why are we not there? So I think that what you're going to start to see, especially around compliance, is this is where you talk about domain-driven software delivery. This domain concept needs to come in, and this is, I would argue, this is why people don't it's not a compliance person problem. It's not a technical person. This is the sociotechnical system. Like then this, you can talk about DevOps, like in governance, like developer and operations were technical people to begin with. Now we're crossing this non-technical chasm where a lot of governance individuals don't have any fundamental basis for understanding what happens in the software realm, and vice versa. Your engineers have no fundamental basis for understanding internal audit and risk management. So I think as we go through this, like, I love this. This is I'll continue to talk about this more and more, but this is why I say get rid of policy as code, because you're not really testing this procedure. But we have to bring these domains, these striations in, and build new architectures that I look at this from more of a business and an information architecture to address these problems.
So like one of the things I love about this frame is the top two, the kind of policy and especially the control objective perspective. And the reason I like it is that, so it's my understanding that Kevin Bear and Gene Kim did a study. And one of the things they found out in the study, it was on GRC stuff. This was a long time ago. I think late 90s, early 2000s. Well, one of the things they discovered was the highest performing organizations had the least number of controls. And you have to hear this the right way, because what the discovery wasn't have less controls. The discovery was have just controls that are absolutely appropriate to what you're doing, that meet the control objectives. Don't have a bunch of controls and not know why you have them, because then you end up with it's like a Pokemon control, right? Like you got to collect them all. That's not the right version of it. So I like that part.
Yeah, you named it. And like out of it too, like when you start thinking about this, like think about this procedure. Like if I have three different, let's say to meet this change control objective from SOC 2 or NIST or ISO, I have this procedure that validates two people reviewed this PR. Well, what happens if I have five Git systems? Like I have GitHub, I have GitHub, I GitLab. Now I have to validate this 5 times. This gets back into the cyclomatic complexity of our software delivery process. And so to your point, like you need to reducing this. You're right. It's not how many more you have. It's, are you effective with the ones you have? And then you have to ask yourself, like, do we really need to add another control objective? Or what part of the stack do we add? And this is why I like this from a guideline is I may not need to add a new control objective, but like from a second line perspective, I may need to add a new procedure or two because I got a new tool or something has changed.
And I think, it's a thing that we've kind of poked at a couple times in the conversation, but just to kind of make sure we bring it in again, I think this means, right, that you take your example about having multiple repositories. Basically, having multiple repositories is an architectural decision about how your software is, source code control system works. And as you've described, that architectural decision makes the system less controllable, right? It's not as easy to control as it would be if you had less. So like, again, I think it will propose doing control like this will propose a new set of things that the architecture should be considering we're doing trade-offs against, right? It can't be simply optimized for one thing. Yeah.
You nailed it. Like, it's going to bubble up the trade-offs. Because like we talked about earlier, like Kubernetes, what's the problem we're surfacing?
Yep.
Bringing a perspective like this helps to surface those problems. So you can think, like, do you keep your 5? Do you say there's a business reason to keep it? Or do you be like, nope, we're going to migrate to 1? Like, you've nailed it. It's the set of trade-offs we're willing to accept to go to market.
Yep. So one more thing, because I heard you say a little bit about it, but I want to make sure I heard it right, or I want to make sure that I hear more about what you think about it. So I've always, like, one of the ways I've always kind of conceptualized automated governance is this idea of specification execution,
Yes.
right? So like in the same way you have things like BDD and some TDD, and the idea is that the specification should be executable, right? You should be able to describe what you want. The requirements shouldn't just be a text document. They should be written in a way that you can execute the requirement against the system, right? So that's kind of like how BDD works. And so I've always thought about, it's like John Willis introduced me to this kind of, I think I can do it the right way. He basically said there was like these phases. He said there's, you go from subjective attestation to objective attestation. You go from objective attestation to automated attestation, right? And basically what his point is there is that the first step increment in value is you automate, you make executable the control so that there's no argument about objectivity and there's no argument about subjectivity. Like, it's not someone's opinion that this is in control. It's in control or it's out of control according to some executable code. Yeah.
Yes.
And then the second thing is that, okay, so if you have something that you can execute, then you can automate the execution of it. So you can build it into your pipelines, you can do other things, but there's this like need to be executable before it can be fully automated. So how far off am I in my understanding from your current thinking about how this should work?
No, you've nailed it. Like, when we start talking about automating governance, the first hurdle is to clearly define, like, this gets down to like talk about making sure a machine can make the decision and idempotence. I need to look at what is the evidence. So there's evidence and there's fact, right? Mm-hmm. So what is the evidence I need to look at? That should be standardized. It's not just did Jabe say it's okay? It's where's the evidence? Mm-hmm. And then the derived fact from that evidence. Does this piece of evidence state that there are 2 or more pull request reviewers? Right. And so once you get that, you're going from subjective to objective. I can objectively see I can give this control, this expectation to 3 different people, including 1 machine, and say, hey, does this evidence show that there are 2 people in there? And when you can do that in an idempotent way, you've now gone from objective. Now the other objective is to continuous verification, right? Now you tend to find the hooks in your system where it becomes important to do those evaluations before you let it go on. So you think about shifting quality left, like you're looking at quality you're now looking at your software delivery process and where are my sort of workspaces? Where do I want the bad quality to stop before it goes forward? Yeah. And then that's the decision you make there when we talk about how to automate. It's really, I don't want to use the word gate, but when do we run these reviews to ensure that what we have meets quality standards up till this point in time?
Yeah. So, but when you were talking earlier, because this is what I heard, and I want, so maybe you could differentiate for me. You had some objections earlier to policy as code. Are you just pointing at what should be what should be objectivized, what should be coded, or is there some other objection that you had to that?
So the policy as code. So if I'm looking at this, policy as code, when we say policy as code technicians, we're looking at very low level things. Like, my policy is not that I should have 2 people looking at a peer request. That's a procedure. My policy is that I need to have change management in such that one individual cannot just make systematic changes without having broader input. So that's my policy. I need broader input, right? Yep. Now, that policy can be implemented in numerous ways. We're just saying at a procedure level, I have a standard that expects at least 2 people. And of those 2 people, the person who did the change can't be a reviewer.
So basically your objective is, your objection is like a naming problem. It shouldn't be policy as code. It should be control procedure as code.
Exactly. And so, like, that's it's because policy is code so ingrained. That's, you're right. It's a naming thing. This gets down to like using the word for what it's meant to be and the domain, because policy as code doesn't mean anything to these individuals. It means something to tech people. But if we start talking and we think about domain driven design and having that ubiquitous language, how do we take like procedure as code could be one way to think about it if we want to continue with the as code moniker, but I'd just call it a procedure. And what we could do is call it a governance procedure and basically say these governance procedure, get rid of the concept as policy as code. Now somebody could make the semantic argument like, well, in the aggregate, this policy is codified. Okay, cool. Like, but like get rid of that, because what you're doing is just remember policy is a high level statement of intent. What we think as policy as code has nothing to do with high level. It is the most minute, specific executional stuff down in the weeds. And so it is opposite to what policy is here. We think policy is code. So that's my rub with policy as code. And it's not that it's a bad idea, because if I'll show you like some stuff from NAPE, like it all looks the same. All these policy engines, they really do the same thing. They're looking for a data element, but bringing this together with the domain of governance, that's where I'm coming from, and saying change the concept from policy as code to procedure. The implementation doesn't change, as you can still use your OPA, your OPA, you could still use your OSCAL and stuff like that. It doesn't change the implementation, but it's changing. It is aligning the semantics with the domain of the governance domain.
And I'd imagine that one of the reasons it would be important to kind of solve for that mismatch is that if you asked a compliance person what policies need to be automated, first they might give you a strange look, like you can't really automate this policy, but also what they will give you is a very high level description, because that's what you asked for. You asked for the policy. Instead, if you said to a governance person, hey, what we're trying to do right now is automate all the procedures. So can you give me all the procedures for this policy? They would go, oh yeah, here's that stuff. And it would then end up being a conversation that was much more reasonable. Also, because maybe even the governance person could look at the procedures and go, oh, yeah, I can see how you'd automate this. I get that.
You've nailed it. And then coming from another perspective too, like sometimes the auditors don't know what procedures need to be in place to meet a policy. And so we think of it back to co-creation. And like, I think the epitome of governance is when actually an engineer can contribute to the positive governance state by adding, either by basically providing procedures to better define control objectives. And so like in that, you can basically have a better conversation now that we've aligned our terminology and we're not like overusing the policy term. So yes, that's exactly it. It's having like back to ubiquitous saying, can we have a non-technical ubiquitous conversation about what we're trying to achieve?
Yeah. I mean, this is domain-driven development. This is exactly what we're talking about. So yeah, cool. I like that. So we've been going for a while, and you should come back and we can talk more, because I feel like we could talk for 2 or 3 more hours easily without even getting into like second tier things. We'd just be like still talking about high level stuff, and that'd be great. As we kind of come to the close, what if people were going to have some takeaways from this conversation, or things that they should research based on this conversation? What are like the 3 things you think they should take away or do more research on?
Yeah. So the first one, since it's all about platform thinking, I like the book, Platform Revolution. There's another one here that is actually, it bashes the concept of platforms and platform business models. So I like the counter. Let me look it up here real quick. Read at least Platform Revolution. Understand platform businesses and how to architect the concept of platforms, not from like this developer looking perspective, but from the concept of a fundamental platform, the three types of exchanges. The other one I was talking about was called the Platform Delusion. It's a really good counter, a bit of a counter to the Platform Revolution. But first thing to do, understand the fundamental models, get out of your software head and start looking at the business model and how the exchange of value happens. Second is really around manufacturing engineering. So I think about platform engineers. I'm using the term governance engineering right now. stop using the word DevOps, not because I stop using DevOps, but start thinking about this, about a systematic approach to engineering and value, which you talked about, Jabe, like designing for manufacturing. We use a lot of these terms, especially supply chain. That's one thing I won't go off on here, but use supply chain. We don't use these terms in technology like they're actually used in physical goods. And it can be a one-to-one thing. Somebody tried to give me an atoms versus electrons excuse. I'm like, no. It can be one-to-one. So research and understand manufacturing engineering and bring those concepts in and, look at starting your own little, like, developer productivity is really just manufacturing engineering at the end of the day, is what I argue. That'd be my second one. And those specifically highly regulated organizations, this is where I'm going to get into governance engineering. So you have the manufacturing engineering, but when you talk about, you're talking about automating governance, set up time. If you're a leader, give some time, give some budget to figuring out how do we automate the procedures. Look at secure controls framework. That's one version of a common controls. That's one I like the most. I believe it's most well written for a broad context of people. But ask yourself and then start to pull this together and say, okay, we need to build a governance engineering group. We need to start looking at this as we are really engineering a new system of design around this. What are the architectures we need to go through? And those are the three things I recommend doing and the actions from here.
Awesome. I'll put the books in the description. If you want to send me any of the artifacts, I can put them in the description so it makes people easy for people to find. If people want to support your work and what you're doing, you specifically, as opposed to just implementing something that you're talking about at their business, how can they get in touch with you? What can they do to support you? Things like this.
So always on LinkedIn, reach out on LinkedIn. Let's connect. Let's chat more. Please don't, if you're a salesperson, don't try to join the sales because it's there to share knowledge, but let's reach out, let's join, let's have some conversations. So we have a LinkedIn group called Governance Engineering. Feel free to join that. I just launched a site, goveng, goveng.io. We are trying to start a movement around engineering, like manufacturing engineering around governance. And what does that look like? It's very new. And so we're really focusing on that. Also, some of the stuff we're talking about policy as code in the next couple of months, you'll hear me talking more about this, about NAPE itself. So you can go look up it. Bensing.io is the organization, and NAPE is not another policy engine. I'll provide the links. But really what I love to do is for anybody out there who wants to figure out how to automate when you look at the secure controls framework, and they want to figure out what it means to automate that, and they really want to solve that problem in their organization, please reach out. I love to share my knowledge with you, what I've learned so far, but also selfishly, I want to learn what you're learning, because from the governance engineering community perspective, what we're working on doing is, can we build this out to be like, could this, not that we want it to be this big next movement. Of course, egotistically, it'd be awesome if it was, but at the end of the day, we see this, like people are doing governance engineering around, and we start, and especially with the book Investments Unlimited that I wrote around there, like there's a lot of people reading this, and it's not like this is new. People have been doing it. And you've said it earlier, like people have been doing this stuff for years. We just want to bring a domain concept to it, formalities around language, ubiquity, such that people can do it better to continue with.
Cool. When's the sequel to Investments Unlimited? Are you going to do another one?
That one's not planned right now, but I really want to. I have ideas for one, so we'll have to wrangle all the 9 co-authors together. And
I know those cats, if you follow what I'm saying. Anyway, all right, man. It was super awesome to have you on. Definitely, we have to figure out how to get you back on and keep going with this idea. Maybe we could just come back next time and talk more about your governance engineering community, and maybe even bring some other people on with you, and we can have a broader conversation.
Oh, yeah.
That'd be cool. Thank you so much. I'll see you soon. And it was nice hanging out with you for a couple hours.
Definitely.
Talk soon,
Thanks
man.
a lot.